we left off in class today. We left off talking about the power of a power rule. So let's look at this practice question from the EOC. So go ahead and pause the recording and try this problem on your own. So remember, when we have an exponent, we distribute it to everything that's within the parentheses. So this becomes x to the 9th to the 5th. Y, remember with y by itself means it's y to the 1 to the 5th. And then it's z to the 4th to the 5th. So remember, when we have a power being raised to a power, we multiply the two exponents. So this becomes x to the 45th, y to the 1 times 5, which is 5, and then z to the 20th. So that matches answer choice J, which is the correct answer. So another exponent rule we have is called the rational exponent rule. What the rational exponent rule says is that if you have a rational number, which remember is a number that can be expressed as a fraction of two whole numbers, that means that the numerator becomes the exponent and the denominator is the root. So it's basically like you took the fraction and then you turn it on its side. The numerator goes inside and the denominator goes on the outside. So let's look at this. We have x to the 2/3 power. So if we're going to rewrite that, that is the same thing as saying x squared, because the 2 is the numerator and then the 3 becomes the root. So it's the cubed root of x squared. So suppose we have 16 to the 1/2 power. If we rewrite that using the rational exponent rule, that's the same thing as 16 to the 1 and taking the square root of it. So anything to the 1 power is that number itself. So this is basically the square root of 16, which equals 4. So let's rewrite this question. And it says 4 to the 1/2 power. So when we rewrite it using the rational exponent rule, that means the 2 becomes the root and the 1 becomes the power. So it's the second root of 4 to the 1, which is the same thing as saying the square root of 4, which equals 2. If we were going to rewrite x to the 2/3, that means that x is squared and we're taking the cubed root of that. Another rule we're going to see today is the negative exponent rule. So that means that if we have something that's to a negative exponent, it's like saying it's on the wrong side of the fraction. So here, we move this to the denominator and that becomes a positive exponent. So let's look at this example right here, negative 5, x to the negative 2. So the negative 5 stays here as itself, and then the x to the negative 2 can be rewritten as 1 over x squared. Okay? So when we combine these two, this is the same thing as saying negative 5 over x squared. So let's look at the other problem. So it says 4 over k to the negative 5. So this negative 5, if we move it, because remember the negative exponent rule is basically telling you to do the reciprocal. So the k to the negative 5, I can make it a positive exponent if I move it to the numerator. So this will become the same thing as saying 4 k to the 5th, because I just move it to the top of the fraction. Okay, so if we're going to simplify this, x to the negative 3, that's the same thing as saying 1 over x cubed. Another thing you need to know is the idea of zero exponents. This is very important because anything to the 0 power equals 1. And it doesn't matter how complicated it is. You can have 10,000 x, y, z cubed to the 0, and that equals 1. As long as whatever is inside is being raised to the 0 power, that's going to equal 1. So here we have a, b squared, c cubed, all raised to the 0 power, and that equals 1. So most of the problems you're going to actually see are ones where you have to combine rules. So that means you'll have to use more than one exponent rule to simplify whatever the problem's being given. So we just go in order. We're going to use order of operations like we would on any other math problem. And you simplify first the parentheses, then work with the exponents, like if you have to use the power rule, then multiply or divide, and then add or subtract if you have any like terms. So this is where we use the properties we learned in adding and subtracting if we have any like terms in the end of our problem. So let's look at this. So we're going to combine rules to simplify 2a squared over a raised to the 3rd power. So we work with whatever's in the parentheses first. So we have the 2a squared over a. So we're going to simplify that first. So remember, this a is basically an a to the 1. So what happens here is we have to use the quotient rule because we're dividing. So this will become 2a to the 2 minus 1, and that's all being raised to the third. So a to the 2 minus 1, that becomes 2a to the 1, and then we have the 3 on the outside. So remember, like we've been doing with those power rule problems, the 3 distributes to everything on the inside. So we have 2 to the third times a to the 1 to the third. So 2 to the third, you can do that on your calculator. 2 to the third is 8. A to the 1 to the third, you do 1 times 3, so that's a cubed. So remember, you always want to keep the same idea in mind. You work with the coefficients separately from the variables, no matter how many different math operations you're doing. So let's try this one. 2x to the negative 3, y to the negative 2 to the fourth, times 3x squared, y to the negative 3. So what we do is we're going to do order of operations. So remember, we do our parentheses, exponents, multiply, divide, and then add or subtract. So I'm going to work within the parentheses, and I'm going to use this exponent first. So I have 2 to the fourth times x to the negative 3 to the fourth times y to the negative 2 to the fourth. And that's still being multiplied by 3x squared y to the negative 3. So 2 to the fourth, once again, you can do that on your calculator because remember, the exponent rules don't apply to numbers. So 2 to the fourth will be 16. X to the negative 3 to the fourth, you multiply them. So that'll be x to the negative 12. Y to the negative 2 to the fourth, that'll be y to the negative 8. And that's still being multiplied by 3x squared y to the negative 3. So now that we've done the parentheses and the exponent, we can do our multiply and divide. So we're just going to multiply all these terms together, and as usual, we're going to pull out the coefficients to work with them separately. So we have 16 times 3 times x to the negative 12 times x squared times y to the negative 8 times y to the negative 3. And that's going to give me 48. Negative 12 and 2, remember when we're multiplying, we're going to add the exponent, so it's going to be x to the negative 10 and y to the negative 11. That's your answer. So let's try this question from the EOC. So go ahead and pause the recording if you want to try this on your own. So like you can see here, we're going to use more than one exponent rule, so we're going to use our order of operations. And so we're going to deal with whatever's in the parentheses first. So this is 36x to the fourth, y to the fifth, over 3 squared. That exponent is going to distribute on the denominator, x squared, y squared. So now I have 36x to the fourth, y to the fifth. 3 squared, remember, is 9. So it's 9x squared, y squared. So I'm going to pull out each set of terms and work with that separately. So 36 over 9 times x to the fourth over x squared times y to the fifth over y squared. So 36 over 9, that's going to simplify. 36 divided by 9 is 4. X to the fourth over x squared, I'm going to subtract the exponents, and that's x squared. Y to the fifth over y squared, I subtract the exponents because I'm dividing, and that's y cubed. So that's how I get my answer, 4x squared y cubed. So here's something to think about. A friend of yours has a homework problem in which you must simplify x cubed to the fourth. He tells you that he thinks the answer is x to the seventh. Is he right? If not, explain where he went wrong. If you look at this, this is expecting you to use the power rule, x to the third to the fourth. So remember, when we have the power rule, we actually have to multiply the exponents. So this is the same thing as x to the 3 times 4, which is actually 12. So x to the 12 is the correct answer. You only add the exponents when you're multiplying the number. X to the 7th would have been the correct answer if the problem had been x cubed times x to the 4th. That's when you add the exponents. You multiply them when it's a power being raised to a power. So now we're going to start looking at multiplying. We're going to do more details on multiplying polynomials in our next live class. But we're just going to start using the exponent rules to multiply monomials with polynomials. And then in our next class, we're going to do multiply polynomials with polynomials. So a lot of the steps we used in adding and subtracting apply when we're multiplying also. You're going to want to start off by distributing to get rid of any parentheses. Then we're going to combine any like terms and simplify. So here's what I mean by multiplying a monomial with a polynomial. So here I have 2x squared. It's sometimes helpful to write this as a chart. It helps you keep track of terms when you're multiplying. So this is one way to do this. So what happens is the 2x squared is going to distribute to everything that's on the inside of the parentheses. So what I do is I write my 2x squared here, and then I have 3x squared, 4x, and 6. And then what I do is I just multiply each term that's on the outside of the box. So here I have 2x squared times 3x squared. Which, if you remember from our exponent rules, this is the same thing as 2 times 3 times x squared times x squared. So 2 times 3 gives me 6. X squared times x squared is x to the 4th. So my next box over, I'm here from the left, I have 2x squared times 4x, which is the same thing as 2 times x squared times x to the 1. Because remember that 4x, that's an x to the 1. I didn't write my 4 here. Okay, 2x squared times 4x. So it's 2 times 4 times x squared times x to the 1. So that becomes 8x cubed. And here I have 2x squared times 6. So this is the same thing as 2 times 6 times x squared. 2 times 6 is 12. So this is 12x squared. And now all I need to do is combine all my terms. I don't have any like terms, so I don't have anything that'll simplify. So this is 6x to the 4th plus 8x cubed plus 12x squared. And that's my answer. Okay, let's try another one. So here I want to multiply 2x plus 3y plus 1 times 3. I'm just going to move the 3 to the front because that's normally how these problems are written. And then remember, the 3 is going to distribute. 3 is going to distribute to everything that's on the inside of this parentheses. So I have 3 times 2x plus 3y plus 1. So this is 3 times 2x. This is 3 times 3y. And this is 3 times 1. 3 times 2x, so 3 times 2 is 6, so this is 6x. 3 times 3y, that's 9y. 3 times 1 is 3. So my final answer is 6x plus 9y plus 3. So using the box is one way to do these. Another way to do them is using the distributive property. You can just draw the arrows and write this as a set of multiplication problems. You can write this as x cubed times 2x squared minus x cubed times x plus x cubed times 4. Or you can draw it out the boxes and use that to keep track of your multiplication. Either way is fine as long as you're keeping track of your terms and using the exponent properties correctly. Also be sure to keep up with negative signs because here it's a minus x. So you'll have to keep the minus as a negative with the x. So make sure and don't lose track of these negative and positive signs. So when you multiply this, your first term is going to be 2 times x cubed times x squared plus, actually it's not plus because it's minus. So minus x cubed times x to the 1 plus 4 times x cubed. So this is going to be 2 times x cubed times x squared is going to be x to the 5th minus x cubed times x to the 1 is going to be x to the 4th and plus 4x cubed. And that is your answer. Now you can multiply this one, 3x times x squared minus 2x plus 1, whichever way you prefer. So I'm going to write it out using the distributive property. So 3x times x squared minus 3x times 2x. Remember, don't forget those negative signs. Plus 3x times 1. So this is going to be 3 times x, which is an x to the 1, times x squared, minus 3 times x to the 1 times x to the 1, plus 3x. So this will be 3x cubed, because I add the exponents, minus 3x squared, plus 3x. So now let's try a couple more problems. So you can do these whichever way you can. You can do the box method or you can distribute. So we have 3xy times 5x plus 2y. So when I multiply this out, I get 3xy times 5x plus 3xy times 2y. So I get 3 times 5 times x times y plus 3 times 2 times x times y times y. So 3 times 5 is 15. X times x gives me x squared. Y plus 6. Then I have x, and then I have y squared. And number 2, we have 4x squared times 5x minus 1. And when I distribute this 4x squared, I get 4x squared times 5x minus 4x squared times 1. So this is 4 times 5 times x squared times x minus 4x squared. So that equals 20x cubed minus 4x squared. So don't forget, if you received an invite to small group, please show up to small group. Also, if you have questions, you can come to office hours or sign up for a one-to-one session. So don't forget, we have our extra class on Friday this week, and I will see you on Friday morning.